Alright, welcome back generals to another Let's Fix Generals 0 hour to make the best game ever. We are still implementing unassemblize tool to aid our Thyme development efforts, and last video we did make progress with printing the C++ code next to our assembler instructions. It looks decent, but I was not able to determine if those entries line up perfectly with the assembler codes. Yeah. So for example, here we have a raw free, C++ is here, it's not here, and I don't understand. This looks suspicious to me here. But at least it is somewhat close, right? Maybe we can look at some other. This is kind of weird. Ah, it's all inline, isn't it? So a translate function. Let's look at this thing. Translate here. Oh yeah, there's a concat inside. So it's probably inlining that thing. Game memory. Already looked at that. How about yeah, we don't have so much here. Any CPP, how about that? Here it doesn't show any code, because maybe there is no code to do. What? It's kind of wild, some of the results here. So it's really wild. Okay, but this sub here makes sense. Subtracting here. Return reds. Okay, let's go ahead and print also the lines. So we need to have ASM printer, print source code. Okay, so source code len. I think we already had this up here, no? Here, this. Let's call the CPP line, code line. Okay. Okay, so line len. We will sorry to truncate. You know what, if this is just called once here, then we don't really need a lambda. We just call it down here. Done. Same for the others. It's just calling it once anyway. Put it here. Guess what we can do is get rid of all the lambda functions. Okay, line number. Line dot append. FMT format. 05D so this is 5, 6, 7 characters. Okay, let's run this. Okay, so we do have line numbers now. I think we can just omit the space here, make it 6. Okay, so we got line numbers, which helps clarifying that these are the same. Okay, so now the question is, should we repeat this all the time? Or just display it at the very top ones? We should probably also print the file name here. How about we remove this header thingy? This here. Okay. And then move this, that. Text file contents. Text file What we can do is we can also save insert content lines. Let's put a content dot name equals name. Source file name. Okay, And then in our printer here, CVP text. Needs to be done here on a higher level. Assembler regions, source codes, regions. Okay. Actually, now it should be 0. Actually, E. Begin. Maybe it should be just an integer. Make it -1. Then we say here if so assert assembler region begin okay, if think this condition is enough. If source code regions 0, 0, zero, zero, zero. One, one, one. And here we say CPP text. CPP text dot pair dot name. Good. File name copy. Yeah. File name copy. And we need to truncate it to truncate line plus codeline. Hold on. Why don't we just pad by this front truncate in place? Region equals source code regions line region 0 assembler region region there we go. Okay, region begin and begin and region minus region dot begin region dot end yeah region region, region. Okay, then here we can also do this. Yeah, this will greatly simplify this logic. I hope it's correct. Here's one. Region. Okay, let's put a breakpoint here. This is wrong. I think we can remove these guys here then. And we can pin assembler. We can put this here. Put this back. This maybe compiles. Yep. Okay, let's see if this works correctly. Good, so region is -1 because we didn't set it yet. Yeah. So here, assembler region here. Source code regions here, here. Same here. There we go. Okay, so we still, oh yeah, now it's correct. 0 to 86, that makes sense, yeah. Good, so it should... Main CPP, then truncate, and misc-boof. Then here we have another region. Okay. Okay, this should work. Let's see. That looks correct. It truncates at the front. Yeah. Okay, I got. Yeah. So I think the text, the formatting and everything, this looks good. The only problem is, now it's percent here. Now we can remove that as well. Look at that. Let's remove that. Okay. So percent D, yeah, that looks good. Okay. Yeah, so now the question is, what do we want to do with all the duplicate texts here? Yeah. So let's check, what does it look like if we so wait, that's the wrong function here. Line number. So we can say here UN16T last line number equals 0. Line number 0. You know what? I do wonder, like our index starts at 0, but do line numbers actually start at 1? Like for example here, our line number in this tool starts at 1. So perhaps it doesn't start at line number 0, but at line number 1. So what if we say let's do UN16T line index is that -1. insert. Line number is not 0. Line index. Smaller that. Line index. Maybe that's the way it should be. Let's look at this way. Yeah. Because to me it looked like we had a little bit of one shift, but I'm not sure. Okay, so let's see. So here's a loop while this makes sense. Here's a jump, free blob here. Okay. Let's see. Aha! Now this is aligned better, isn't it? Yeah. Okay, this alignment looks pretty good now. Yeah, so I think that was the issue that I thought I saw, that it was shifted by one. Can we get some other sample here? Yeah, this is definitely an assignment. Morph that. Yeah, this looks good. Yeah, here we have a call, allocate, yeah. Yeah, this aligns much better now. I like it. I like it. Creates, blob, yeah. This aligns pretty well now. I like it. Return, let's see. Yeah, I guess. Memset. Mm-hmm. Okay, let's here, last line number, we put that to 0, and we can remove this here. Last line number. We put that to here if it's a lot of conditions. So if last line number does not match instruction line number, then we keep on moving. Here, next. And then we assign last line number that. Make this const. Okay, append. Yeah. Okay, so basically this should now prevent reoccurring lines to print the same C++ code. So we just get the C++ ones. Let's see. Oh, but it also skips a line number. I want the line number. Yeah. Then Then we do it just here. Line on plus line on. Jeez. There we go. Yeah, we can do it like this. So it gives us a cleaner view on the code, but still shows us the lines. Yeah, I think this makes sense. Yeah, I think this is good. Yeah. Mm-hmm. Yeah, I like it. It's pretty good. Obviously, with text, it's kind of hard to look at this, so we definitely need a UI, but just to lay out what we currently have, this looks pretty solid. Yeah. Yep. Okay. And next step, we should probably actually, I think for starters, this is already good to submit. Okay, let's test append bytes. Make it customizable. Let's put this here smaller to like 6, for example, 7. And let's go to main. ASM output. No. here. Let's make it more compact. I have another idea. No. Actually we could, yeah. We could do the following. No, we can't. No, we can't. We can't. Advanced debugging. Print indent then equals to print ASM len. Let's put it to 60. Let's go to ASM printer. Let's put this to 60. Okay, let's run this and let's take a look how this looks. A little bit more dense now, less bytes, everything. Yeah. Okay, cool. Yeah, this looks pretty solid. Yeah. Yeah, looks pretty cool, I would say. Okay, how about we clean this up here and we make a new fresh generation. Okay. Okay, let's send it here to our code browse. I have implemented source line plus exabytes printing. The columns can be generated with custom length. My generation 60 chars for C++, 7 bytes, 60 chars for ASM. Appears to work well. Good, so we have an update. Yep, it looks good to me. Oops. So we can I don't know what that is. Yeah, so I guess we can clean up our change, fill the gaps, and then afterwards submit it, and then we can implement the command line arguments. Yeah. Okay, let's clean up here a little bit. Yeah. We still have the question about reserving stuff here. Yeah. The question is, can we do that? Let's add a to-do here. Make this customizable. Okay. Yeah, so the reserve len, the problem is we already append the string here, so it grows once, twice, and then reserve again, so 3 times at least. Yeah. Misc buff reserve. Yeah, so Can we optimize that? I don't know. It would be nice to just reserve the string with one size so that there won't be any reallocations, you know. Well, there will be reallocations. Yeah. Maybe it's not worth it to reserve the string. Maybe we just let it double. That's it. Yeah. So what we can do is we simply here we make a text reserve, and we reserve for, I don't know, how much do we output right now? So for example, we have, yeah, we can reserve for, I mean, hold on. No, it's exact. We just, hold on. Okay, how about we do the following? We just take out this string here. We put it here, text. Then we reserve, like, I don't know. A megabyte. Let's reserve a megabyte. 1024 times 1024. That's one megabyte, I think. Yeah. And then here we just clear it. And we do the same in the other function. Eh? Here. No. Jesus. FS here. Pen to string process ASM opera. So this just okay here. Yeah, it doesn't matter. Okay, no, I think that is good enough. We just reserve with a nice buffer, and if it doubles, it doubles. Yeah, I think that's easier. Then here we just say we remove all this. We remove all this. Remove this assert, and boom. Easy. Easy. Okay, it looks pretty clean to me. We also have like a small misc buffer here and the lines. This one is reserved. Right. Our buffers. Print buffers. Yeah, I would say. So right now they're private. Now they're public. Print buffers to string. Okay, then print buffers. Print buffers. I would say we make this now a non-static function, and we create a member here, private. And we put a print buffers here, buffers, muffers, buffers. Maybe we rename it to just buffers. And then we go here to this function. Well, this one we can leave static. This one not. Okay. So we do here buffers. Keeps buffer allocated. Keeps buffer allocated for reuse. Okay, now we need to change all these buffer thingies, yeah. Yeah. Okay, and then in the runner, we create here ASM printer instance, and we do printer dot append string. this should keep allocations to a minimum, I think. There's one more thing. So here does a resize. So there will be things inside the strings, right? On a second run. Let me see. So the misbuff is cleared before use. Okay, that's fine. See, misbuff. Oops. Misbuff, clear, yeah. It's also cleared here. Good, okay, so that works. Clear. It's not used here. It's not used there. Okay. So the misc buffer is always cleared before use, but the lines, they are not here. Lines. Pen source code. Yeah, okay, so what we need to do is we need to first clear it once, clear, and then resize. That may or may not allocate, depending on how much. Yeah, I think that's fine. Okay, let's see how that looks. Yeah, yeah, yeah. That's cool. Okay, then let's see what else we can clean up here. So, yeah, let's see. We did a lot of changes. Yeah, this is actually a huge change. A couple days now took. Yeah. Yeah, it looks pretty good. Yeah. Yeah. I would say we finalize this in the next session. I think I have earned a little break. Usually I just code many of the last videos I just coded until the end of day and then I went straight to bed. But maybe today I can have like an hour break before going to bed. Yeah. Okay. Yeah, I think I'm very happy with the progress. So certainly we got all data now in place to facilitate all the things that we want to do. Print the assembler, compare the assembler, print the bytes and the source code, and have them bundled into compilants or source files from the PDB. Yeah, to have a little bit of structure. Yeah, I think that is pretty good. Yeah. Yeah. The last thing for this effort would be then to add the command line arguments to control the length of the source code and the bytes. Yeah. That's it pretty much. Yeah. I would say implementation wise it should be rather performant because we don't unnecessarily allocate all the time. We try to reuse our allocations. We don't do much wild lookups. It's all going through arrays from start to finish with some conditions here and there. So it should be fast. Yeah. I think performance will be okay. We tested in debug. I wonder. Yeah, I guess in release it will run quite a bit faster. Yeah, maybe not too much. I don't know. How long does it currently take? Well, we can't see. A few seconds. Yeah. Well, I think there will be a time when things will be too slow, but then we can look into what we can do to optimize. There's always something to optimize. Well, hopefully something big. If things are slow, then hopefully there's something big that can be tweaked with not too much effort. Yeah. Good. Yeah. I think it's fine. Yeah. Yeah. Good. Then next session we will prepare submitting this, and then we do the command line arguments, and then I think we can go to the UI. Yeah, the end boss. to visualize everything nicely. Yeah, because with text file, I mean, it's not bad, but it's also not great because, I don't know, you need to, I mean, it's not bad as a text, like, yeah, but it's, I don't know. Yeah. Yeah, but I think it's pretty cool to be able to see, like, okay, here we have the C++ code. This is our assembler. And here it's this mismatching. What is it? Right. So it right now, it shows all the information we need in this text file. Yeah. Yeah. What could also be done is to have like a summary file, which gives like a high-level overview over everything, like how much is matching, how much is mismatching, like just on a function level, right? So it shows, it gives you, it lists these files here, and then it lists the function names, and then it lists how much is matching. Yeah, like a summary. Yeah, yeah, yeah. All right. Yeah. Then I think I would take a break now. I wish you a great day or night. Until next time. Goodbye.